Good day, stats enthusiasts. Welcome to this AI-assisted learning session. Today, we'll explore a powerful statistical tool, the Mantel Haenszel Test. If you're ready, then let's begin. Once again, hello everyone. Welcome to this quick dive into an important statistical tool, the Mantel Haenszel Test. But before we get into the details, let's briefly touch on the definition of a non-parametric test. A non-parametric test is a statistical method used when the data does not necessarily fit the assumptions required by traditional tests, like the normal distribution. Now, the Mantel Haenszel Test is a non-parametric test developed by Nathan Mantel and William Haenszel to analyze stratified categorical data. Simply put, it helps us understand relationships between variables across different strata. The Mantel Haenszel Test really shines when you're working with multiple 2x2 contingency tables. Think of these as simple tables comparing two outcomes, like yes versus no, or present versus absent, across several distinct groups or strata. These strata could be anything relevant to your study: age groups, gender categories, geographic locations, or any variable that might influence your results. What sets the Mantel Haenszel Test apart is its ability to control for confounding variables, those hidden factors that can sneak in and cloud the true relationship between the variables you're actually interested in. For example, if you're studying the link between a treatment and recovery, but different age groups respond differently, age becomes a potential confounder. This test helps you factor that in. Unlike a standard chi-square test, which pools all your data together and might miss those subtle differences across subgroups, the Mantel Haenszel Test stratifies your data. It looks at each group separately, then combines the results in a way that gives you a more accurate and controlled overall picture. It's like adjusting the lens on a camera. You focus in on the details while still seeing the whole image clearly. When using the Mantel Haenszel Test, it's essential to understand and meet a few key assumptions to ensure valid results. First, the variables you're analyzing must be binary. That is, each variable should have only two possible outcomes, like yes or no, success or failure, or present or absent. Second, the observations should be independent. This means that the result or value of one observation should not influence or depend on another. Think of each data point as a separate voice in the dataset, not an echo of another. Third, and just as important, is consistency in the direction of association across all strata. This means the relationship you're investigating, for example, whether exposure increases risk, should follow the same trend in each subgroup or layer of your data. First, the variable. A second-year bachelor in mathematics student wanted to find out if receiving a good luck message from a crush could affect exam scores in 3 high schools: Alicia National High School, Cochran City National High School, and Santiago City National High School. Exam results from a 60-item test were grouped as high, scores of 45 and above, or average to low, below 45. In Alicia National High School, 30 students who received a good luck message were in the high score group, while 10 were in the average to low group. Among those who did not receive a message, 20 scored high and 40 scored average to low. At Cochran City National High School, 25 students with a good luck message scored high and 15 scored average to low, while those without a message included 18 high scorers and 37 in the average to low group. In Santiago City National High School, 20 students who got a message scored high and 20 scored average to low, while among those who did not receive a message, 15 scored high and 45 scored average to low. Now, Let us use an amazing app to conduct this test based on the data that we have. We are going to use Jamovi, a free and open source computer program for data analysis and performing statistical tests. Going back to our sample, the first step that we must do is to open our Excel and check for our raw data. Second, let's open the Jamovi app. In the top left corner, you can see a hamburger button, the white 3-line icon in the top left part, beside variables. Click Open and then browse through your files until you find the specific file that contains your raw data. Wait until the app opens your data. Third, if you would like to rename your data for a better understanding of context, you may edit it by clicking the Title tab twice. Now, since we already have our data in our Jamovi, we can proceed with the test. To do that, click the Frequencies and select Independent Samples Test under the Contingency table. After selecting the test, your Jamovi should look like this. We can now insert our data. The score group will go to the rows, the good luck message will be our columns, and finally, our confounding variable will be our layer. To do the Mantel Haenszel test, open the Statistics panel and there will be choices that will appear, one of which is the Mantel Haenszel located under the ordinal, along with Kendall and Gamma. Click that and wait for the result to show in the right side of the screen. Now that we have the result, our next step will be to interpret the result of our test. A Mantel Haenszel test was conducted to examine the association between receiving a good luck message and achieving a high exam score, while controlling for the confounding effect of school. The comparative measures showed that the odds of achieving a high score were significantly lower for students who did not receive a good luck message across all 3 schools. Specifically, the odds ratios for Alicia National High School, Cochran City National High School, and Santiago City National High School were 0.17, with a 95% confidence interval from 0.07 to 0.41, 0.29, with a 95% confidence interval from 0.12 to 0.69, and 0.33, with a 95% confidence interval from 0.14 to 0.78, respectively. The combined Mantel-Haenszel odds ratio across all schools was 0.26, with a 95% confidence interval from 0.16 to 0.43. This indicates that students who did not receive a good luck message had approximately 74% lower odds of achieving a high score compared to those who did. The Mantel-Haenszel test for trend was statistically significant for each school. For Alicia National High School, the chi-square value with 1 degree of freedom was 16.50, with a p-value less than 0.001. For Cochran City National High School, the chi-square value with 1 degree of freedom was 8.20, with a p-value of 0.004. For Santiago City National High School, the chi-square value with 1 degree of freedom was 6.53, with a p-value of 0.011. Overall, the combined chi-square value with 1 degree of freedom was 29.97, with a p-value less than 0.001. This suggests a consistent association between receiving a good luck message and higher exam scores across all schools. In summary, there was a significant association between receiving a good luck message and higher exam scores, even after controlling for school. In summary, the Mantel-Haenszel test helps you make more accurate and reliable conclusions about your data by controlling for confounders. It's a valuable method whenever you want to compare groups fairly and understand the true effect of your variable of interest. Until next